Thank you. So like I said, I'm Kevin Richardson. I'm with Halt the Harm Network. We're helping to host the event tonight with FracTracker. I'll be doing your technical assistance. So please, if you have any technical issues, just message me in the chat. Can you go to the next slide? Cool. I'll just give you a little background on Halt the Harm before I pass it over to my colleague, Erica Jackson from FracTracker. So Halt the Harm is a network of grassroots leaders and individuals and supporters from across the country who are fighting the harms of oil and gas extraction. We encourage people to come join our network. We have a campaign network and a directory of leaders across the country. Through both, you can get in touch and share resources with people who are fighting oil and gas across the country, as well as in your area. So I highly recommend you check those out. I'll drop some links to it in the chat in just a minute. And if you get to the next slide. Cool. And just a couple more things about Halt the Harm. First off, after tonight's presentation, you'll get a brief feedback survey, which we hope you'll fill out. Halt the Harm also has a resource about fracking called frackingnextdoor.com, where you can search for all sorts of interesting resources and information on fracking. That's really helpful, that we built with Mountain Watershed Association. And then there's some links to the Halt the Harm Net. And if you are with a group that wants to do a webinar around oil and gas issues, feel free to reach out to me. There's my email address, and we also will help you host webinars like this. Cool. I'll drop some of these links to the chat. And with that, I'm going to pass it to Erica Jackson from FracTracker, who will introduce our speakers and tell us about FracTracker. Take it away, Erica.
Thanks, Kevin. Great to see everyone here today. So thanks for sharing your evening with us. My name is Erica Jackson. I'm the manager of community outreach and support at FracTracker. And I'm speaking to you all from Pittsburgh, Pennsylvania, the ancestral lands of the Adena, Hopewell, Delaware, Shawnee, Haudenosaunee, and many other tribes. You know, kind of surrounded by a woodsy area where there's a lot of chicks. So if you can go to the next slide, Anna. And one more, just in case you're not familiar with FracTracker Alliance, we're a nonprofit that maps, analyzes, and communicates the risks of oil and gas development to advance just energy alternatives that protect public health, natural resources, and the climate. And one of the more elusive and challenging things that we map are pipelines, and specifically gathering lines. If you're not familiar with that term, don't worry. We have two really great speakers who will break it down for you, and who are doing some really important research to advance understanding of this topic. So if you can go to the next slide. First, you'll hear from Jack Warren. Jack is a former FracTracker intern and current research analyst at the Environmental Defense Fund. He'll give us a brief background on gathering lines. And then we'll get to our main speaker, Anna Abel. Anna is our current environmental health fellow, who I've had the pleasure of working with over this past summer. And she'll present her research on making the connection between forest fragmentation and the spread of Lyme disease in Southwest Pennsylvania. So we'll have time for questions at the end. If you have them, you can put them in the chat, but we'll save those for the end. And then we'll close out with a quick way that you can get involved in this research. So now I'm excited to introduce you to Jack Warren. Jack, like I mentioned, is a research analyst. He is investigating methane emissions from the oil and gas industry for the Environmental Defense Fund. His work focuses primarily on the Permian Basin of Texas and New Mexico, where leak rates are abnormally high. Before being hired by EDF, Jack worked with us at FracTracker, and he studied gathering line networks in Pennsylvania. In his spare time, Jack enjoys climbing and is an avid bird watcher.
Thank you for the introduction, Erica. Before we get into forest fragmentation and Lyme disease, I just want to give you some background on pipelines and why understanding their impacts is so important. So fundamentally, pipelines carry oil and gas production along the supply chain and can be broken down into two types. So first are the gathering pipelines, which you heard Erica mention before. And these bring products, oil and gas, from the wellheads ultimately to processing facilities. And these are usually smaller pipelines relative to the other type. And their networks of them can be very complex and cover an entire area. Processing facilities, oil and gas is brought closer to the products that we use in our everyday lives. And then they are transported along large transmission lines, which are huge pipelines. They're probably the type you're actually very familiar with, as the development of any new ones often make national news. But the management of both transmission and gathering lines is extremely important. Of transmission lines alone, there's over 300,000 miles of pipeline in the US, which I know is such a large number that it's hard to imagine. But that's enough length to wrap around the equator over a dozen times. So if you go to the next slide. With a system so large, it has numerous impacts on our human well-being and the environment. Here we are looking at a map by FracTracker of pipeline incidents in the United States from 2010 to 2021. And in yellow, you can see incidents along pipelines that resulted in human injury. And in the red triangles, you can see when that resulted in a fatality, with other minor incidents marked by the color of dots. Pipelines can also leak, if you go to the next slide, resulting in sort of damage to our environment. Here you are looking at an infrared video of a pipeline leak in the Permian Basin of Texas and New Mexico. The leak itself, you can see, is coming out of the black gas that's coming out of that clear area there. In infrared, natural gas, which is normally invisible, is viewable like black. And so this gathering pipeline is emitting large amounts of methane, a potent greenhouse gas that is over 40 times more powerful than CO2 at warming the climate in the short term. If you go to the next slide, and lastly, as you'll hear more about later, the clearing of land for oil and gas development can have numerous impacts on our wildlife. With the links provided in the chat later on, you can read a FracTracker story map about some of the birds affected the most by fracking development in northeastern Pennsylvania. So in order to start investigating some of these impacts, next slide, I worked on developing pipeline data sets with FracTracker. So to do that, we were comparing satellite imagery across different time periods and tracing when area was cleared for gathering line construction using the satellite imagery as well as points of where the wells were themselves. With others at FracTracker, we were able to map out most of the gathering pipelines in Pennsylvania, Ohio, and West Virginia. We were able to use this data in Bradford County specifically. If you go to the next slide, where we compared our results with the county records of those same gathering pipelines. So on this map, the county record is outlined in purple, while what we trace at FracTracker is what appears in black with an orange fill. And at this scale of the map, it appears that, roughly the county record versus what we saw actually in the ground is about the same. Maybe there's just a minor difference due to the projection or overlaying the different data sets. But if you go to the next slide where we zoom in, and you can really see here where the trace is coming out in orange and that county record is in purple, you can see that from the trace data sets, there are entire lengths of pipelines and intersections that just aren't in the county record at all. And so what we concluded was that the disparities in these data qualities ultimately leaves the communities unprepared to manage the impacts of oil and gas development. And hopefully in building out these public data sets, we hope to enable research to better understand these impacts. Following that theme, you'll be hearing from Anna Abel. Anna is a graduate student in George Mason University, working on her Master's of Public Health. She has experience in GIS and creating data web visualizations and researching social issues. Prior to her internship, she worked at a research group at George Mason University, analyzing health workforce supply and demand data to create user-friendly data visualization tools. Like many at FracTracker, and myself included, she enjoys spending time outdoors and hanging out with her cats. And so with that, I'll hand it over to Anna for her to talk about Lyme disease.
Thank you, Jack, for that introduction. Hi, everyone. My name is Anna, and I have been working as the Environmental Health Fellow at FracTracker for the past 3 months on the project that I am presenting today on the relationship between Lyme disease and pipeline right-of-ways in southwestern Pennsylvania. But before getting into some of my research methods, I'm going to share some background information to help you all understand how these two things could be connected. So for starters, the area that I was interested in researching was southwestern Pennsylvania, and the counties I included in my definition of southwestern Pennsylvania were Greene County, Washington County, Allegheny, Westmoreland, and Fayette County. The total population of these combined counties is about 2 million people, and most of these people live in Allegheny County. That's where Pittsburgh is. And a lot of you might already know this if you're familiar with FracTracker's work, but in the early 2000s, hydraulic fracturing, also known as fracking, became a popular method of oil and gas extraction because it allowed access to products that were otherwise difficult to reach with traditional drilling methods. So as you can see from this graph, conventional wells were already being built in southwestern Pennsylvania before the early 2000s and peaked around 2005 to 2009 before quickly dropping off, whereas unconventional wells didn't start being constructed until 2005 to 2009, and then they steadily increased before seeing a slight decrease from 2015 and 2019. So these wells are oftentimes built in forested areas, and it's estimated that each well can take up to 30 acres of land, including all of the additional infrastructure needed for each well. So this includes pipeline footprints, which require a 50 to 100 foot width right-of-way be cleared for the entire length of each pipeline. So here are just some images where you can see how oil and gas infrastructure cuts through forests. And then I used the National Land Cover Database raster files from the US Geological Survey from the years 2001 and 2019 to calculate the difference in forest cover between those 2 years. And I found that 31% of the total forest loss in Pennsylvania was located in southwestern Pennsylvania. Considering that southwestern Pennsylvania only accounted for about 9% of the total forest cover in all of Pennsylvania in 2001, this is a rather extreme amount of forest loss for the area over this period of time. Additionally, several studies done by the US Geological Survey on the increase in forest fragments in Pennsylvania counties found that approximately 67% of new forest fragments in southwestern Pennsylvania from the years 2001 to 2010 could be attributed to natural gas development. Forest fragmentation is an important concern because of the impact that it has on biodiversity and species distribution. It can limit species by decreasing their habitat size, increasing exposure of some species to predators, and by increasing the spread of invasives. One example of a species that has been negatively impacted by oil and gas infrastructure is the woodland caribou in Canada. Due to the increase in infrastructure in their habitat, the species has been pushed to higher elevations where the climate is tougher, and this has caused survival rates to decrease. And as Jack mentioned earlier, another species that could be negatively impacted by oil and gas infrastructure in forested areas is the cerulean warbler and other forest interior birds. These birds experience habitat loss when clearings for wells and pipelines are made, while other birds that are habitat generalists are able to outcompete forest interior birds because they are less affected by these new forest clearings. So now I'm going to share a little background information about Lyme disease. Lyme disease was originally discovered in Lyme, Connecticut in the 1970s, and it was mainly concentrated along the northeastern coast, but it has since spread west and down through the mid-Atlantic. In Pennsylvania, Lyme disease was mainly concentrated in southeastern Pennsylvania at the beginning of the century, but it has since spread to every county of the state. And two of the biggest factors believed to be contributing to the spread of Lyme disease are forest fragmentation and climate change. So in terms of what Lyme disease actually is, the disease is caused by the bacterium Borrelia burgdorferi. and species such as the white-footed mouse act as reservoirs for this bacterium. Black-legged ticks are the species that actually transmit Lyme disease to humans through a blood meal. Black-legged ticks take blood meals during 3 stages of their life cycle, so they could feed on a species that has the bacterium at an early stage in their life cycle, and then at a later stage, they could feed on a human and transmit Lyme disease to them. And in terms of how the spread of Lyme disease relates to forest fragmentation, white-footed mice, which are a common host for black-legged ticks, have been found to outcompete other small mammals when their habitat size is reduced. And additionally, the white-tailed deer, another common host for black-legged ticks, have been found to prefer grazing along forest edge environments. So the most common or most recognizable symptom of Lyme disease is the erythema migrans rash, which is like a bullseye-shaped red rash around the infected site. And other symptoms can include muscle aches and fever, along with a whole list of other symptoms, which if you're interested, you can find that on the CDC website. Additionally, some people do experience more intense delayed symptoms. These can include facial palsy, arthritis, and swelling, among other delayed symptoms. Luckily, Lyme disease is treatable by oral antibiotics, but it is possible to experience something called post-treatment Lyme disease syndrome, where a person still experiences symptoms for several months after treatment. So now that you can hopefully kind of see how pipelines and Lyme disease could be connected, I'm going to get into my research methods for studying the relationship between the spread of Lyme disease and the construction of pipeline right-of-ways in southwestern Pennsylvania over the past 2 decades. So as Jack talked about earlier, there's very limited data on pipeline locations, especially gathering lines. And there's also very limited data on when exactly these pipelines were constructed. Because of this, it's very hard to actually study how changes in Lyme disease rates over time could be related to the construction of pipelines over time. So in order to do this, I came up with a couple of proxies for pipeline construction. These proxies that I used were the cumulative number of wells drilled from 2001 to 2019, the average change in oil and gas production from 2001 to 2019, and I created an estimate of the total miles of gathering lines in each Pennsylvania county based on data on other types of pipelines. To get these variables, I collected data from the Pennsylvania Department of Environmental Protection on the number of wells drilled in each county annually, as well as data on oil and gas production in each county annually. And for the oil and gas production variables, I found the difference in production between each year and calculated the average for each county in order to get the average annual change. In terms of the gathering lines estimate, this was the more complicated proxy. I collected data on other types of pipelines that were available through the Energy Information Administration. And I created a proportion of pipeline miles in each county based on this data. I then multiplied that proportion by 425,000 because that is the estimated number of miles of gathering lines throughout the United States. And all of my variables were also divided by the county area so that they could be comparable. So I used the pipeline proxies in a multiple linear regression model where the outcome was the average annual change in Lyme disease rate in well drilling counties of Pennsylvania from 2001 to 2019. And the exposure variables were the pipeline proxies, along with, I included a couple covariates, which were the change in forest cover, change in forest edge, and average annual change in population, all from 2001 to 2019. I also mapped all of these variables so that you can kind of see which counties were most affected by each one in a visual way. So this is the average annual change in Lyme disease rate. This is the cumulative number of wells drilled. This is total change in forest cover, total change in forest edge, and the average annual change in population. And I can go back to these later if you guys want to look at them more closely. But as I mentioned earlier, I used multiple linear regression to model my data and see if there were any statistically significant associations between my variables and the average annual change in Lyme disease rate. I created 4 different models, and I used one for each of my pipeline proxies. And I found that the model that fit the data the best was the model using the cumulative number of wells drilled variable as the pipeline proxy. And this was also the only model where the pipeline proxy was statistically significant. And if you don't have a lot of statistics background, that's okay. I'm just gonna run through a couple of terms to help you understand exactly what the model is basically saying. So the intercept estimate basically represents the average annual change in Lyme disease rate when all of the exposure variables are equal to 0. The variable estimates represent the amount of increase or decrease in average annual change in Lyme disease rate for every 1 unit increase in the variable. The standard error is the average variation in each variable estimate. And the t-value is how many standard deviations away from the null that the estimate is. And the p-value is the probability of observing a value more extreme than the estimate. And the p-value is also what is used to determine statistical significance. So for example, for every 1 unit increase in cumulative number of wells drilled, the average annual change in Lyme disease rate increased by 0.4284. And the variation for this estimate was 0.1864. The estimate is 2.98 standard deviations away from the null, and the probability of observing a value more extreme than the estimate is 0.0276. So based on my modeling, the variables that were statistically significant were the cumulative number of wells drilled, the change in total forest cover, and the average annual change in population. As you can see, the change in total forest edge was not statistically significant, which I was kind of expecting it to be, but this could indicate that there were also other variables affecting these findings that were not included in the model. So because only one of my pipeline proxies was significantly associated with average annual change in Lyme disease rate, this could indicate that the association was a false finding. However, it could also just be that the other pipeline approximations were not good estimates of pipeline construction over the past 2 decades. For example, oil and gas production tends to have a lot of variation from year to year. So even if 1 year there's a drop in production, there still might have been a lot of pipelines being built. Additionally, the estimate of gathering line miles is based on the assumption that the construction of other types of pipelines is proportional to the construction of gathering lines, which I cannot actually confirm. And also this variable isn't based on temporal data, so it assumes that all gathering lines have been built within the past 20 years. And there were likely a lot of gathering lines built within the past 20 years, but definitely not all of them. So based on this information, the cumulative number of wells drilled was likely the best approximation for the construction of pipelines. Also, the significant findings for this variable could indicate that not only pipeline right-of-ways, but also well pad infrastructure in general could contribute to the spread of Lyme disease. There are some limitations to these findings. For instance, since the data I collected was only available at the county level, the results of my study can only be interpreted at the county level and not at the individual level. So I can't say that because someone lives in an area with more wells, they are more likely to get Lyme disease. But I can say that these results suggest that counties with more well construction were more likely to have a higher average annual change in Lyme disease rate. Additionally, because I use counties as my observational unit for the modeling, the sample size was relatively low because I only included 40 counties in my model, and this could decrease the precision of my results. And lastly, even though the cumulative number of wells drilled model fit the data the best out of all of the models that I ran, the adjusted R-squared value, which represents how well the data fits the model, was still relatively low. This value was only about 0.33, which could indicate that there are other variables that should have been included in the model to help explain the variation in average annual change in Lyme disease rate. For example, including data on the annual change in temperature in each county would have probably been a good variable to include, because other studies have found that the spread of Lyme disease is associated with climate change. However, I did not have this data, so I couldn't include it in my model. So I want to emphasize that the research I did for this project was mainly exploratory. There has been very little research that I could find on the relationship between oil and gas infrastructure and Lyme disease spread, but I think that it's definitely a topic that should be given more consideration. My findings do indicate that there is a potential association, but I definitely don't think that it's all cut and dry, and there are likely additional contributing factors to the spread of Lyme disease that I was not able to include in my model. I mainly hope to use this research as an opportunity to get people to consider the ecological impact of oil and gas infrastructure, and to emphasize the fact that changes to species diversity and spread are not only detrimental to habitat specialists, but also can be detrimental to human health. I also wanted to use this research opportunity to bring awareness to the lack of data on pipeline construction. This type of data is important for studying the impacts that oil and gas infrastructure has on the environment and on human health, but it is not well documented and not publicly available. So here are my references, and I'm just going to end on this temporal map that I made on well drilling in Pennsylvania over the past 2 decades, and I can start taking questions.
Cool. Thank you for all of your research, Anna, and thanks for the in-depth explanation. We're gonna move into our Q&A portion, and as Anna mentioned, we can start taking questions. Feel free to raise your hands to come off mute and ask questions. If you're in a place you're unable to, you can also drop your question into the chat. And I know if you're on a phone, you can't raise your hand. We also welcome folks to come off mute and ask it if that's necessary. So looks like PK has a question first. PK, you can go ahead. And also, when you ask your question, just give us.
Hi, thank you so much. This is an amazing presentation and exploratory work. This is great, wonderful work. So I am also affected by Lyme. I was curious, when you're doing data collection, I know how hard it is to get that data. And one thing I found is I've asked my veterinarian what's coming on, like what kind of co-infections and what they're seeing out there before the doctors hardly know. Lyme is there's a lot of Lyme illiteracy out there. So one of the places, I mean, I know it's hard, it may not be publicly available, but there's less restriction in HIPAA and whatnot, and veterinarians have a lot of information. I'm not sure if it's statistically relevant, but it might help with tracing some data or getting more data, because, animals are absolutely affected by this as well. And I'm just curious if anybody's looked into that. Thank you.
Yeah, that's definitely a good point. I hadn't considered looking at data that veterinarians have, but I'm sure they have a lot of good data about Lyme disease, because dogs can also get ticks. But yeah, the data I used was from the Pennsylvania Department of Health, and I know that data set's probably not the most complete, because a lot of people don't properly report their Lyme disease cases, or they just don't realize that they have Lyme disease. And also people get misreported for Lyme disease as well. So expanding data on that is definitely important.
Cool, thank you for that question, PK. One question I also want to throw out there is, well, not more so much a question, but I was wondering if you could speak a little bit more about the kind of relationship between Lyme disease and climate change, because that's sort of an indirect connection to oil and gas here, and something you spoke a little bit about at the end.
Yeah, so I think that even if I can't make a direct association between Lyme disease and pipeline right-of-ways, oil and gas infrastructure is contributing to emissions, which is contributing to climate change. So I definitely think that there's still a connection there, even if it's not as direct as I was trying to make. So yeah, I definitely think that whether or not pipeline right-of-ways contribute to Lyme disease, there's still in some ways a connection.
I think I'll actually add to that, that I think the area cleared for sort of fracking and pipeline right-of-ways, as Anna mentioned before, often favors animals that are generalists. Like in the context of birds, these could be like crows and other sort of species and not your forest interiors, like Anna mentioned. But outside of for a lot of your mammals that are habitat generalists are often vectors of Lyme disease. So before you even incorporate the sort of climate change element, just the land clearing part and increasing the amount of deer or the amount of mice that can thrive near a oil and gas site versus in an interior forest interior habitat will be increasing the sort of vector species that can propagate Lyme disease. So there's sort of this interesting two-pronged effect, and yeah, really, really cool research, Anna.
Thank you. Barbara has a question in the chat. She's asking if there are any estimates for the magnitude of underdiagnosis of Lyme disease.
There are, I don't know the exact numbers. It is on the CDC website, and I can send it to you later if you're interested.
Cool. And Barbara also has a practical question too. What's the best interval of time after a tick bite to do a test of the blood antibodies to find evidence of Lyme disease?
There's this place in Pennsylvania. If you live in Pennsylvania, there's this place called I think it's just the Pennsylvania Tick Lab, and they will take ticks at any stage. I don't think it matters how long afterwards, but you can send your ticks for free if you live in Pennsylvania. If you don't live in Pennsylvania, you have to pay a fee, and they'll test for you.
Cool. And another question about infrastructure. Have you been able to uncouple oil and gas right-of-ways from other types like high voltage electric lines?
Yeah, I'll take that question since it focuses more on the mapping element. That is the first sort of big right-of-way that competes in our mapping. So when you're comparing, the first thing when you're trying to map out where the pipelines are is that you're mainly looking for where forest clearings are. And when you're trying to map it through open fields, that's when it gets more complicated. As you pointed out, sort of electrical lines are also cleared away in a similar fashion. But thankfully, when you're comparing satellite imagery from different time periods, you can easily tell that there are electrical lines there because you can see the stands that they're up on and you can see the lines themselves. Even in cases where you don't actually, it's hard to make out due to the resolution, you can't make out those electrical lines. They're constant and running through directly to sort of city or people's homes, while as the networks of gathering lines curve between locations of well paths. And so while that element can complicate whether you wanted to build like an automated machine learning model that could do this work, when you have a human reviewing it, you can use these other factors to delineate whether it's a sort of right of way for an electrical line or a right of way for a gathering pipeline. It's a good question because I looked into automating a lot of this, and that was the first complicating factor.
And Erica has another question for you, Jack. Is there a reason why leakage rates are high in the Permian Basin as compared to other basin shale plays?
Yeah, that is a big and complicated question. Fundamentally, the Permian, I'll start that. Fundamentally, the Permian Basin is an oil basin, whereas the Marcellus Shale of northwestern of Pennsylvania, Ohio, and West Virginia is primarily a natural gas play. And so the sort of fundamental characteristics of what kind of material they're trying to get does change the sort of nature of how emissions come out. So in the Permian Basin, you can see a lot of venting and flaring of natural gas because the main thing they're trying to get at is the oil itself. Whereas in the Marcellus Shale in Pennsylvania, Ohio, West Virginia, the product they're trying to get is the natural gas. So they're often better. They don't employ the same practices and they don't emit in similar ways. So you have to sort of use the other process level comparisons when comparing different oil basins.
Yeah, it's a very good point. I live in the Barnett Shale area, which is also focused on natural gas extraction, and it's a different kind of set of problems from flaring and direct release, for sure. Next question is from Sarah. Have you looked at the vector distribution data sets instead of Lyme surveillance data?
So I did consider this, but the Lyme disease data was just a lot easier for me to access, and it was just more complete. So I thought about using the vector data, but it was just easier for me to use the Lyme disease data. But in the future, maybe that could be something that is researched.
We have another sort of technical question from Linda. What is the prevalence rate of Powassan virus in pinna ticks?
That I do not know.
It's a good question. And we have lots of good information about Lyme disease and testing in the chat. I encourage folks to go check that out. And yeah, keep the questions going. We still have a little bit longer for our Q&A. And I'll throw one more out there for you, Anna. If you have folks on the call who might want to continue this kind of research or look into this issue further, what sort of direction would you point them in for a follow-up?
Yeah, I mean, I definitely think there needs to be follow-up on this. One thing that's really important is just getting more data, publicly accessible data on pipelines so that we can actually see this relationship directly, because I don't think the proxies do a good enough job at that. And then also, one of the things that I had hoped to do as part of my research was to go out and collect ticks and get them tested for Lyme disease. But because of the time frame in the life cycle of ticks, it wasn't going to be possible. So that's something that could be done in the future as well.
While people are thinking of questions, I know that when people are sort of researching the impacts of sort of pipeline right-of-ways and forest cover change and relative to birds, they can, researchers can go out in the field and then do sort of surveys to measure how many birds are present relative to different sort of pipeline right-of-ways or oil and gas wells. Can a similar sort of sampling method or surveys be done for tick research?
Yeah, I assume so.
Probably a little bit less fun than going and looking for birds with a pair of binoculars, but not needed nonetheless.
So the thing that I was planning to do was I was gonna, there's this thing called tick dragging where you have a white cloth and you kind of just drag it along the ground, and after a couple meters, you check it and see how many ticks are on it. And then you keep doing that for a while, and then you get them tested. So that was what I was hoping to do. And I guess that's kind of similar.
Yeah, that's fascinating. I had no idea that's one of the methods for collecting ticks. That's really interesting. It's so simple in that respect. Oh, Barbara has a question. I heard one environmental investigator state that deer like the gas right-of-ways, perhaps because there is more forest edge. And I guess that also, I'll add to that question, are there ways to sort of modify infrastructure to kind of prevent some of these problems and make it more, I guess, well, let me rephrase that. Is there a way to modify infrastructure in order to kind of reduce fragmentation, or is it really that we just didn't have the infrastructure at all?
I don't know if there's, I'll answer the first part first. So yeah, the point that I was trying to make about the deer is that they probably do prefer using right-of-ways because of the forest edge. And I don't know that there's really an established method to prevent, to limit like forest fragmentation or Lyme disease caused by forest fragmentation. I know similar research has been done on the on like suburban sprawl in Virginia and how that has caused increased Lyme disease in forested areas, because as the suburbs move out into forested areas, they creep into these territories where ticks are located, and that's been a major cause of Lyme disease. So that's also another contributing factor that should be considered as well.
Definitely. And to sort of address some of the mitigation part of the question that you asked, Kevin, it seems like either the answer could be very simple. It's like, oh, if you can just minimize the amount of intersections through core forest area, that would be one way to sort of mitigate the sort of ecological impacts. Or if you could sort of just optimize the sort of paths of gathering pipelines. That's the sort of simple answer you could give just looking at it surface level. But when you consider the sort of historical process of this development, wells are popping up at different times. There are mergers and acquisitions, transferring well ownership to new companies. And then a new company builds a new pipeline to go out to a different section of the well, and sort of stacking up all of these events in a time series complicates it in a matter of fashion. And that leads you away from that sort of idealized path where, oh, if all the gathering pipelines could just route through this one corridor, maybe we built through a forest, the sort of human process level elements of the oil and gas industry sort of go against that. And so it's ultimately kind of a complicated issue.
I'll just add to that. The trend is that gathering pipelines, at least, are getting much larger in size, and just from some trips that FracTracker has done out in the field, we're seeing a lot of times right-of-ways are much, the standard is saying that they're like 50 feet, but oftentimes they're much wider than that. And that's kind of part of the problem with the fact that there aren't publicly available maps for that, is that these can actually be really large pipelines. For example, like the Revolution pipeline in Pennsylvania, I see you have Karen on the call, by some agencies' records, that was considered a gathering pipeline, and that was one that exploded. So finding good maps on that was difficult. And so it's definitely an impact that needs to be taken seriously. And I can, oh, sorry, go ahead, Jack.
Oh no, I was just going to sort of add to what you were saying. The sort of documenting of where the pipelines are and that sort of record keeping is also just important from the planning and construction perspective, because FracTracker has documented many examples from where pipelines get put in sort of hilly areas where there's landslides or clearing of the ground, and that ultimately wears on the infrastructure much faster and can cause some of the incidents that I highlighted before. And sort of it isn't good for the human well-being of those communities, and it also isn't it is not the business intention of whoever built the pipeline itself. So really the documenting of it can improve all elements of this.
Yes. If we don't have any more questions, I can take us to our final section to close us out. But if there's any last burning questions, feel free to speak now. Let me put the link to Anna's report in the chat one more time, so you can read it. There's lots of maps, interactive map, and GIF maps and regular maps, and some charts in there. So definitely take a look. Like Anna mentioned, we're hoping to look for ways to continue this research. So if you're interested, reach out. And thank you all so much for sharing your time. And I also want to say a special thanks to Jack and Anna for your research on this topic. It's really oftentimes overlooked when we're thinking about oil and gas impacts. And I know that your research has helped broaden the way I think about the ways oil and gas impacts ecosystems and different species, and then that in turn comes back and impacts public health. So I hope that FracTracker's continued research on this is helpful to all of you all who joined us tonight. I see a lot of great organizers and activists and researchers on the call, which is awesome. And I'm going to close out with share my screen about one way that you can support, or let me make sure I'm on the right slide before I share my screen. Ways that you can support this work. So we are able to crowdsource mapping data through our mobile app. The app is free on Google Play and the App Store. It's available in English and Spanish, and it has two main components. So one is a map of wells and pipelines and compressor stations and processing stations that you can use if you're out in the field and or out in your neighborhood and want to see what's around you. And the other feature is a place where you can submit reports of infrastructure or impacts, be they noise impacts, smell impacts, site, or just different developments that you see happening around you. We use these reports to better understand how the oil and gas industry is impacting people on the ground. And it can also be really useful in giving us more complete data sets. So this map shows all the red dots are where people have reported pipelines, and you can click on them and see what people are reporting. And we can use those to literally connect the dots and draw pipeline routes to improve that information for everyone who wants access to it. So again, you can download that by searching FracTracker on the App Store and Google Play. And I also want to just share our contact information, my contact information and Anna's. We can also put you in touch with Jack, I guess. Sorry, Jack, we left your email off of here. But definitely reach out if you're interested in learning more. And I guess the final note is after this, you'll get an email with a follow-up survey, which we would love for you to share your feedback and also thoughts on additional ways that FracTracker can support your work. I'll stop sharing and just say again, thanks so much to Anna and Jack for your awesome research and everyone else for joining us tonight.